Okay, welcome back to our geometry videos. This is regular geometry unit 7, problem number 37. And just got to use a bunch of different types of things that we know about different relationships here in geometry in order to set up an expression to solve for the variable. So this first one looks like an isosceles triangle. I know in an isosceles triangle these two angles are congruent. So 6n minus 3 equals n plus 17. I am going to move all the n's to the left, and I'm going to move this 3 to the right. So 6n minus n is 5n. 17 plus 3 is 20, which means we divide both sides by 5, n is 4. In this particular one, we got two variables. We have x there and there, and we have y there. So probably most of us look at this right away and notice the vertical angles and say those two are equal, and you're right, those two are equal, but we're going to have trouble finding anything if we set those equal to each other because we have two variables. So we're going to have to start with these two angles, which I know are supplementary. Those add together to be 180. So 7x minus 19 plus 3x plus 14 equals 180. 7x plus 3x is 10x. And we have negative 19 plus 14, that's a negative 5. So 10x minus 5 equals 180. Adding 5 to both sides, we get 10x equals 185. Dividing both sides by 10, we get x to equal 18.5. Okay, now that we know that x equals 18.5, we can plug that back in to this part to figure out what that angle actually is. So 7 times 18.5 minus 19, let's see what that is. 7 times 18.5 minus 19, that angle is 110.5 degrees, which means 110.5 degrees is the same as 5y minus 2. I'm going to add 2 to both sides. So 112.5 equals 5y. Divide both sides by 5, and we get y to equal 22.5. Okay, so kind of a interesting one there. Right, we had to use two relationships here to show that the angles were supplementary in order to get the value of x. And then once we found the value of x, we could find out what an angle was, which we knew was vertical to the expression for y. Okay, the next ones here, we have a parallelogram. These two angles are supplementary. They're on the same side of parallel lines cut by a transversal. So actually kind of fact we just used in the previous one. 3w plus 5w plus 36 equals 180. So 8w plus 36 equals 180. We'll subtract 36 from both sides. So 180 minus 36 is 144. Dividing both sides by 8, we get w to equal 18. And then the last one here goes back to our law of cosines. Right, we have a non-right triangle. Two sides that we know, one side we're trying to find. So this looks like k squared equals 15 squared plus 25 squared minus 2 times 15 times 25 times the cosine of 120. And then I'm going to literally just plug all that right in the calculator, exactly how it looks, just like that. Just checking on the degrees here. Okay, so 15 squared plus 25 squared minus 2 times 15 times 25 times the cosine of 120. That enter, that whole thing works out really nice actually. To 1,225. We take the square root of that to get 35. Okay, we're probably not used to those problems working out that nice, but this one just happens to. Okay, if you have any questions or comments on that, feel free to leave a question or comment. Just noticing one thing real quick here on this particular one. If you wanted to solve this a different way, there's probably a different way you could do it if maybe you didn't know the law of cosines. You could create a right or two right triangles here, drawing a perpendicular there, and then using some information about the sides to get the angles from there. But I probably stick to the law of cosines on first glance at that one. So, yeah, again, if you have any questions or comments about how we set any of those up, feel free to leave a question or comment. Otherwise, you're more than welcome to like, subscribe, or share to our geometry videos.